So hi all. Welcome to today's .NET Meetup. I hope you can hear me all. Good. Hi to today's April 2020 Meetup. I'm Andy, and I'm today's host. After me, then Martin is speaker of the day for getting started of Kubernetes. So let's start to get to the talk. So first, this meetup is organized by .NET Devs.at. We are a non-profit organization about bringing knowledge about .NET technology to you. We have a website, we are on Twitter, we are on Twitch, as you're currently seeing. We are on YouTube, all of our recordings are uploaded there, and there's also a Slack channel where you can talk with us, where the parts of our community are there, and we can help each other out there. You have the links in the chat. Don't need to get all the QR codes for now. Yeah, thank you to all for joining. We're on 37 viewers currently. Cool. And we also want to thank our sponsors. We are only online. We are getting sponsored, and we're getting sponsored by Tieto. So thank you for them. And before we come to the talk, some small news from the community. There is some new program community stuff from Microsoft called Azure Heroes. These are some digital stickers, collectibles, what you can get. It's a new community initiative from Microsoft about all stuff Azure learning for the community. You have to have some stickers. There are different. So community hero, content hero, inclusive leaver, mentor, maker, and learner. And what you can do is first you can get these badges for the ones technical. This is implemented via blockchain. So you get you have this badge in your blockchain. I will also post a link for this QR code here. So with this link you can get this badge into your blockchain in your wallet. And yeah, this is this learner badge says, yeah, you're learning stuff about Azure. There's no limitations on users. So everybody who is participating in such an event as today can get this. This badge is valid until tomorrow, 12. So if you want to have it collect this stuff, make it now or a little bit later. You can also redeem this afterwards on the websites. Yeah, you have more information on this link, or search for Azure Heroes. There you can also nominate people from the community who you think is does stuff for the community like we do, and you can nominate them, and then it will be checked if this is meeting the criteria, and then this person gets this badge. So I want to try it out. It was really easy. So this was my first getting in touch with the blockchain when I tried this out. At least I would say for at least that to try out once the blockchain. Try it out. It's really easy, and yeah, cool. And this was it. So from the news, Now it's Martin's talk, Martin's time, with getting started with Kubernetes for your .NET application. Martin, are you ready?
Yeah, ready as I can be. Also from my home office, I hope you can all hear me. Hey, so, yeah, thanks for having me again. I've been working with Kubernetes now for quite a while, also now in a production application, and also working with a customer to get our applications into Kubernetes environments. And I wanted to give you a bit of an overview because I've noticed that a lot of people have not yet used Kubernetes, which I think is very tragic. So I hope I can give you all a bit of an introduction to Kubernetes, especially from a developer's point of view, because I feel that usually developers try to get more into infrastructure, but also that deploying things, and I think also a lot of people who work with Kubernetes are really more on the infrastructure side. And I think Kubernetes is basically a contract between application developers and infrastructure management. So I think it's good to get both perspectives and to basically understand most of the abstractions in there. So hi, my name is Martin. I work at T2Every Austria. You can find me on these platforms as well. So hit me up on Twitter, or I sometimes also post to Stack Overflow, and usually MS Build stuff. But the agenda for today would be, I'd first try to give you a bit of an overview over a few technologies, so a bit what's in containers. I also want to show you a cool piece of software called Rancher. And my demos will also be based on Azure Kubernetes Service. But all of the things I try to tell you today should be applicable to any Kubernetes environment. So on Google environments, on Amazon, but also on on-premise installations. Then I will also give you a bit of a deep dive, and so we can really get into code or YAML files, which we all love and hate at the same time, and also deploy a .NET sample application. So let's get started. Actually, the first thing I find quite interesting about all these containers and Kubernetes stuff is the terminology involved, right? So basically everything is in nautical terms. So everything is based on shipping things and steering boats. So that's quite interesting. So in German, this is Seefahrtsterminologie. But yeah, we have our container ships that go to docks to get containers. Then they also have these whale things. And actually, it's pronounced Kubernetes. Like I notice a few German speakers usually say Kubernetes. It's actually Greek. Kubernetes is actually the pilot of a ship, or the helmsman, basically. And also Helm is also technology that's used with Kubernetes. And Helm is basically the steering wheel, Steuer in German. And also if you encounter other technologies like Istio, which is the sail, or in .NET there's a tie for the knots that you use on while sailing. So everything is very, very nautical terminology. Yeah, that's the Greek pronunciation. Right, so I think previously, just to get back into containers, the way I like to describe containers is we do have some OS-specific concerns in how we deploy things, but I think most of the developers usually spend most of the time on the right side, like spending time developing application-specific assets. But then only when we want to deploy stuff, we basically create this one magical document, like how do we install our application. And containers are actually putting all these things together in a box, so we can ship it as a container. And you would think that this installation document would go away, right? But actually, I think it's more, we turn that configuration into source code. So for building containers, we basically codify our installation document into a Docker file. So we basically tell how to create this container. So we create a script that does all the installations. And I think it's very, very similar for Kubernetes, just that we don't tell how to compile and deploy the software with all the application and operating system components, but more for the application in general. But building a container is simple, but the reality is that apps tend to get quite complex very fast. So we usually want to run multiple containers. We have apps that sometimes talk to a database, and maybe we need to deploy the database as well. Sometimes we have microservice environments that need to scale different parts to service independently. Then we also want to have this communication set up, some load balance in between them, and also manage that thing on multiple hosts with host resiliency, so that when one of our nodes gets down, has a hardware fault, then we can use the others as well. And also we want to do rollouts ideally with zero downtime, which is fun to do with applications that need database, but Kubernetes gives us building blocks to solve a lot of these problems, right? So these are things that are called orchestration. And previously, there have been a few competing technologies. I think we've all heard of Docker Swarm, which was Docker's main product for orchestration. There was also, or still is, Apache Mesos, which is also basically a scheduler, which is also the basis for a few other applications. But I think Kubernetes has actually won the war between orchestration platforms. So I think Kubernetes is what we should really focus on, because Kubernetes has gained a lot of momentum over the last years. So we've seen a lot of industry growth, and it's basically now the platform of choice for building large-scale or redundant container-based applications, right? And even major companies now write about the usage of Kubernetes, and we see a lot of investments going on there. And also especially from the cloud providers like Amazon, Microsoft, and Google. So I actually like this graphic a lot. I stole it from the .NET team, which is in most of our applications, especially in distributed ones, we have a few concerns that we need to deal about all the time. So we have things like logging, configuration, and sequence. We want to do deployments in a repeatable fashion. When we have multiple containers, we also need some form of service discovery. And then we also want to have some diagnostics, observability into what's going on between them. There's also communication protocols involved. And of course, we want to build our domain-oriented microservices, serverless stuff. But the idea is that Kubernetes helps with a lot of these things. Yeah, it takes away a lot of concerns. So, for instance, Kubernetes has mechanisms for service discovery, which up until then you would usually deploy some custom service, like use. No, I think I already forgot what we use, but yeah, that's also etcd and something where we would store configuration. We would have things that dealt with service discovery, where we have a service registry that we can query how to talk to each other. And basically, Kubernetes as a platform helps us solve a lot of these base concerns in a very abstract fashion. So it works on every environment that supports Kubernetes, whether that be some on-premise service or some cloud service like Azure Kubernetes Service. So I think I've said Kubernetes a lot of times, but actually, what is Kubernetes? So at its core, Kubernetes is basically a set of libraries and executables that talk with APIs. But the problem is, I think it's like the Linux kernel. Like, you can have a Linux kernel, but that doesn't make an operating system. So usually you want to have some kind of distribution that packages all these components up in a way that allows you to install it to a platform. Things that you would usually use, for example, so single node test deployments, some distributions you can use on bare metal on-premise services, or some vendor platforms that come with cloud vendors or infrastructure vendors that in data centers. So there's lots of different ways. So you would usually not go to the Kubernetes repos and build the binaries and run them. You would usually get a distribution or go to a vendor platform, right? And there are multiple. Some are open source, like the Rancher Kubernetes engine. There's also commercial ones like OpenShift, and also the vendor platforms like Azure Kubernetes Service, Google Kubernetes Engine, I think. And of course, Amazon has their own as well. So the idea is really that those platforms also configure Kubernetes the right way, because Kubernetes, I'd say, is more of an abstraction. So if you're deploying it to Azure, you want to integrate with Azure itself, which is why you want to use the configured vendor version with all the vendor plugins. And when I say abstractions, I mean, really you would specify your application says, yeah, here's my container, here's my application, I need these things to run. So usually at the very bare minimum, you need some form of networking, right, to get TCP traffic. And you could get these by different ways. You could have like overlay networks over your on-premise infrastructure, or if you run in a cloud, you want to integrate with that cloud provider you're running on. So, for example, in Azure, we would have the Azure networking plugin, which allows us to use Azure VNets, which we can connect our hosts to. So we can use IP ranges in VNets and use networking features available in Azure, so that we could integrate with different things. But also we could integrate with on-premise infrastructure, right? So if you have like Cisco routers, I think there's a plugin for that. So that's the thing where you would configure Kubernetes itself to integrate with the hardware that you have and the infrastructure that you have, and then deploy the application that specifies how it connects together. And those things basically meet in the middle, right? Also, a good abstraction is storage, because in every environment you deploy, you have different types of storage, right? You can have like a NetApp or a fiber channel based storage system on premise, but maybe some Azure disks where you just say, yeah, I want an SSD instantiated somewhere and then connected to my host, and I want to use it. And also maybe also some file-based storage, or Amazon S3 storage, block storage, something like that. This is also something you would solve via plugins, because when we create the application, we only deal with the abstractions, right? The developer specifies I need 10 gigabytes of storage for my database, right? Give me storage, and then the system you deploy to would talk to the infrastructure that is configured against to actually make the storage available for you. Usually you would get a few choices, like you would say, yeah, I want fast storage or I want slow storage, but how this is configured below is basically an infrastructure concern. And also Kubernetes allows us to integrate with load balancers. So in Azure, we would have Azure load balancers, so that when we tell Kubernetes, yeah, I want this service because this is a UI, I want it exposed to the public, it would create a public IP address and set up a load balancer to all of your nodes, or you could use internal load balancing as well. And that works for Azure, and Amazon has also a load balancer. You could again integrate with different on-premise systems like from Cisco, or you can use I think the new hotness is Metal LB, which is a very lean layer for load balancer. So that's also very interesting. But again, I think these abstractions are really the power of Kubernetes itself, right? Because as a developer, we would only specify, yeah, I have an application, I have some web component that runs on an Nginx container, I have a worker service that does something, and I have a database that I want to deploy. And Kubernetes would then try to instantiate these things on the host, right? So I think a good analogy that I've recently come across is actually Tetris. So Kubernetes would then try to play Tetris to distribute the things among the hosts. And also it would do the things that the application needs. So for example, my database needs persistent storage, right? So in Azure, we would provision an Azure disk and connect the container that runs the database to this disk as well. And if something goes wrong, like for instance the host fails, Kubernetes would then look at the current state, which is, yes, things are not working, and the desired state, and try to fix it by starting up the container on a different host and connecting it to the same persistent storage. So Kubernetes is not only for transient containers and stateless stuff, but you can and you also should have state in Kubernetes, because you would separate these concerns of storage from compute, and whatever storage provider is used on the cluster that you run on will be managed by Kubernetes. And as an application developer, you don't really have to think too much about that. Another good example is to do scaling. So, for example, we experience some additional load. I don't know, maybe we're an online shop and everyone has to order from home because we're in lockdown. So we need to scale up our shop service. Maybe not the UI frontend, because it's a single page application and Nginx only serves static files. So we would say, yeah, we no longer need one instance, we need 3 instances now. And Kubernetes would try to update the current state to the desired state and instantiate 2 more instances of this service. And of course, because we had a bug in there, at some point we want to deploy a new version and we don't want to go offline. So we want to update our system, tell, yeah, we now need the newer version, 3 instances. We don't want to have any downtime. So the default strategy for if you use deployments in Kubernetes is it would just create new versions of this container and then gradually kill the old ones, so that there's always a minimum of containers running with any version, and then you would do a rolling upgrade to make sure you get to the new version without any downtime. Also, what's very useful, especially when you get started with Kubernetes and want to experiment a bit, is the concept of namespaces. So usually we have a cluster that's made up of different hosts, but you can create kind of virtual clusters on top of that using namespaces. So for example, if I have 2 different applications or maybe 2 different versions of an application, like a production and a staging environment, you could create 2 different namespaces which would act as virtual clusters, and then basically deploy these applications into the different clusters. So you can have multiple instances of the same application, different applications, and if you use management tools like the CLI or use a dashboard or some other tool, you would really only see what's in that namespace. You can basically drop the whole namespace and it would drop everything that was deployed into it. So that's a very useful feature, especially when you get started and start playing around with Kubernetes. So I've also showed you nodes. The truth is there's actually multiple roles of stuff that runs in Kubernetes. So we've got our nodes here in the bottom right, which they are the main thing that run our software. But there are a lot of management services involved. Usually you will have nodes that deal with management concerns. The good thing is when you use a managed service like Azure Kubernetes Service, you would usually have these management roles taken care of by the cloud vendor, and you would really only deploy the nodes and manage the nodes that are connected to Kubernetes. So that's the power of managed services. But of course, you can always deploy, if you do an on-premise installation, you would usually deploy a few nodes or instances of these management services of the control plane, and also have your compute nodes as well. And I think in AKS, you only pay for the nodes themselves. Yeah, and this is how it looks in Azure. So we only manage the node pool. The Kubernetes version is taken care of by Azure, and we just tell it, yeah, I want this size of nodes and this many instances. So I think this is really the power of managed services, because setting that all up by hand is actually quite cumbersome if you do it in an on-premise installation. There's also a few things that help with that, which I'll come to later. But if you want to get started and try something out, I really suggest you get started with a managed service of your favorite cloud vendor. Right. But especially when you try to scale up and also try to use Kubernetes in enterprise environments, you may have a few concerns that are not taken care of by like bare or vendor Kubernetes installations. Like one of them, Kubernetes does have a dashboard, but sometimes you need a more feature-rich UI. Also, sometimes you have to manage multiple clusters. For instance, if you do multi-region deployments or deploy to different cloud providers or to different on-premise installations, you would have to manage multiple clusters as well. Also, you may want to do role-based access control, so only the right people have access to the right maybe namespaces or maybe even applications. That you maybe also want to integrate with existing authentication solutions, right? So if you're using Azure AD in your organization and you want to manage an on-premise cluster that you have in a factory, you can integrate that. It's a bit cumbersome, but there's a thing that helps with that, and that is Rancher. So Rancher is in open source software. So Rancher Labs, the company behind it, makes money through selling support. The idea is you have this management platform that you can connect existing clusters to. They can also manage deployments of clusters to different environments. So if you create an Azure Kubernetes Service cluster, and you have a Rancher instance running somewhere, you can just tell Rancher, yeah, please configure this cluster for me. But if you do on-premise deployments, there's also the Rancher Kubernetes engine, which is a very helpful way to deploy on-premise clusters because it's basically a Dockerized form of Kubernetes that's very easy to install. And what you get from it is he's an interface you can import existing clusters or deploy to your favorite provider. But I think the really cool stuff is you get a nice front end that gives you a lot of developer access. Like you can get the config to connect your CLI tools to, and you get most of the management features for all the types of resources that you would have in Kubernetes. So I also think if you're getting started with Kubernetes, that's also a really helpful tool to have, especially if you don't remember all the commands. That's very helpful to do, right? Dashboards and role-based access control, where you could, for example, manage namespaces and make sure that different clusters can only be accessed by people of your organizational unit that should be able to do that. So that's very helpful to do in an enterprise environment. So basically you can deploy it to a server. So the thing is, Rancher would run outside of your cluster. Like I think the official recommendation is you should have a Kubernetes cluster running your Rancher to manage other clusters. So I think that's overkill if you try to get started with a small deployment. So I'd really suggest spinning up a very, very lightweight machine with the Rancher Docker container, connecting it to Kubernetes, and then start playing around with Kubernetes to get started. And of course, there's also a way that you can package applications up and deploy them with a tool called Helm. I'll show you a demo of that later. But Rancher also has a user interface for that, so I can also specify questions that I would like to ask the user when they install a Helm application. So I could use this format to create a UI that actually is able to ask questions and have the user click around and fill out these forms, right? Any questions so far? I don't see any in the chat, but I need a short break anyway. Heavy vendor login. So
Kubernetes platform sounds like a heavy vendor login.
Yeah, so I think I've talked about a lot of these vendor-specific integrations. I think Kubernetes is actually what gets you away from the vendor lock-in, right? Because you would develop your application against Kubernetes using these abstractions, and depending on which provider you deploy to, your application wouldn't have to change for that. So, for example, we're currently working with a customer where we have some systems in Azure, but also some systems on-premise, with a completely different infrastructure, right? And also completely different storage solutions, but we don't have to change any of our application. So This is the good thing, that Kubernetes is basically the middle ground between having an abstraction that we can develop our application against, so that we can ask for these kinds of things to help our applications. So we specify what we need, and what we actually get from the cloud vendor or the on-premise systems, that is provided by the Kubernetes installation itself. So I think it actually helps you get out of vendor lock-in. So if you have Azure, what's it called, web jobs and integration with some service bus systems, that's probably a heavier vendor lock-in than using Kubernetes as an abstraction. Right. So next thing is I would go deeper into Kubernetes and starting to use it. So what I will do is show you the building blocks that you can use to create an application. Then I want to deploy a small application with you, and then also package it up and see how we can deploy it using things like a Rancher UI. Sound quality got bad. Is it getting better? I'm just talking. Oh, you're hearing me double, so.
No, we hear you double.
Yeah, I can't actually hear myself. So, okay, now it's okay. Okay, so in Kubernetes, the main building block that's the smallest unit is called a pod. Usually a pod is something that has its own IP address and it can run one or more containers. So previously I've said you want to deploy containers. So at the very core, you can think of a pod being just a container. You could have multiple containers. They would be able to communicate on localhost, but a pod is really the smallest unit of things that you can deploy together. They get their own IP. They can talk to stuff outside of it. They can also interact with storage. So there are some scenarios where you could use multiple containers, like if you have a web server that serves HTTP requests and some kind of cache storage and another service that pulls content from somewhere. But really, all these together packaged up is really a pod. So you would schedule these things together, you would scale these things together. And yeah, so actually let's do an example of that. So the way this works is in Kubernetes, basically everything is a YAML file. So I like to say Kubernetes is just a bunch of YAML files that became sentient. So the way this works is in Kubernetes, we basically always create these kinds of definitions. So we would have a YAML file with an API version that says, yeah, this is a pod. We would usually specify some kind of metadata, like a name, and then have a specification. So this is basically the blueprint of how to create a pod. In this case, we're using the BusyBox image, which is a very, very lightweight Linux tool distributions. Just write something to std out and sleep for a while. And I think the most important or most interesting thing is actually the resources. So I've previously mentioned that I like to think of Kubernetes as being some kind of Tetris engine. And if we think of Tetris blocks, this tells us how big the block is, right? So we would specify, please only schedule this on nodes that have this many CPU and this many memory available. But we can also specify a hard limit so that when one pod runs, tries to use all the CPU, it can't do that. Just for information, this unit is milli CPUs. So this now would be 0.1 CPUs. And the way we would do this is using the kubectl command, kubectl or kubecontrol. So I'll start a service that watches what's going on in the cluster. So there's currently no resources in there. And the way we would do things is we would use kubectl, apply a file pod YAML. So here's the specification. This is what we want to have. And now it says, okay, this is a pod. It's now the status container creating. Now it's in state running. And what you also see happen is, right, we sleep for 10 seconds. So what's going to happen is the container is going to exit, right? Now it says completed, but now it says running again, because it actually thinks that the pod failed. So it will try to restart it, because we're doing desired state configuration. So we say we want to have this running. So there's also a control loop or reconciliation loop going on, looking at the current state, looking at the desired state, and trying to restart the pod, because we specified that we want to have it running. Now you see also a crash loop back off, because it doesn't try continuously restarting. There's also some back off involved. But we can also use kubectl to also look at things that are going on inside these pods. So if you've used Docker before, we would have Docker log for getting the logs. We can do the same with kubectl. So you can kubectl logs demo pod, and we can also follow this. I think we should, yeah, so we get the std out output. Also, if I go over, I've already set up a Rancher instance. So in this case, Rancher has things called projects where you can manage your namespaces with. But here in the workloads, we would see this is the pod that's running. You can also see the log output there. Could also start the console in there when it's running again. Yeah, but now it's backing up for 40 seconds, so that's going to be a bit much. So the way I delete this is kubectl delete pods demo pod. And now it terminates the pod and cleans it up, right? But the thing is, one pod is actually not very helpful on its own. So the next thing we want to do is actually scale a pod, and this is where replica sets come in. So in replica sets, you basically say, yeah, I want to have this kind of pods this many times, and that's it. You would usually not use replica sets on your own, but I think it's quite helpful to understand the layers of abstraction involved, right? Because in a replica set, what we would do, this is now also a YAML resource. In this case, it's not a kind pod, it's a kind replica set. We also give it a name, but now it's there's a little more in there. So it also has a specification. The idea is you specify how many instances you want, and you also specify a template. The idea is there's always like a loop going on, a control loop, looking at the current state, looking at the desired state, and you need to match up the status like, are my pods running? And you would do this using labels. So for example, here is a template. So the replica set would instantiate pods using this pod template. In this case, an Nginx server. And then the replica set would continuously check, are there still 2 instances of a pod matching the label tier frontend running? And if not, it would instantiate more instances of this template. Also, what I'm showing here is that on these pods, you can also specify public ports that can be used to connect to this pod. In this case, it's a web server. So we want to connect to it via HTTP. So in this case, let's deploy this. Actually, the first thing I usually do when I'm setting up an environment is I don't like to type too much. So I created an alias for kubectl with just kc. So I'm going to kc apply my replica set. And what we see now is that we deployed this replica set, which has like a desired and current state, and it would create multiple pods. And now what you also see is that these pods have some random suffix at the end. So we can't really predict a lot of things that are, how these things are named. We just have to live with it. But this is how this looks in Rancher. So we got our 2 instances here. And if you want to have this kind of look, like this is just a watch, we would be able to do kc get. And I could write pods here, but everything has a short name. For pods is PO, for replica sets is RS. So we would have our state in there. Actually, because I've now deployed a web server, you would usually ask, yeah, how can I connect to this web server? And what you can use there is a tool of kubectl called port forward. So you can set up direct port forwarding to some ports in your cluster. And in this case, I want to deploy to one of the ports. So this is just connected to one, but I can use the replica set as a target to the demo front end on port 8080, mapping to port 80. So 8080 is my local point. Port 80 is the container port from the pod. So it's set up port forwarding. So I should be able to connect to localhost 8080 and get direct TCP traffic into my cluster into one of these pods running Nginx. So then what I could do in production is I would say, yeah, I'm having more load. I want to scale this up. So the way I could do this is change the YAML file and apply the YAML file again. But there's usually also a command that can do the same. So I can use kubectl scale this replica set demo front end and set replicas to 3. So it would scale up, create a new pod, and I can scale down again, or actually I can apply the file again with the 2 in there, so it would terminate one of the pods to get to my desired state again. So that's very useful. The thing that it can't really do is, like, for example, when I'm saying, yeah, there's a new version of Nginx, I want to use that one instead. So we upgrade the application by the patch version, and we want to deploy this YAML file again. It would actually do nothing, right? We've applied the thing because replica sets only have a very, very simple control loop. So it says, yeah, there are 2 pods running, matching our labels, so it's going to do nothing. So this is where deployments can come in. Let me just clean up again. You can also use key C delete and apply this file. To delete all that stuff. Right, the next layer of abstractions would be deployments. So deployments are actually one layer above replica sets. So deployments would create and manage replica sets. The idea is that you would use deployments to implement rolling updates or recreation updates that allow you to do exactly that, namely change what's in these pod specifications. So I've also have one prepared. So in this case, this looks like exactly like a replica set, only now it's a kind deployment. It works in the same way. So we specify how many replicas we want. We have a template, and we match what is currently running against what should be created, also using labels and match labels. So if one pod with the label tier frontend is running, it would create another one because the desired state is 2. But we can also specify deployment strategy. So in this case, I talked about rolling updates as well. There's also a recreate strategy. So let's change that to rolling update. Actually, the rolling update is, I think, is the default. So if we do nothing and apply this deployment YAML file, what we get is there's now more things deployed. So now there is a deployment with a ready state and now a replica set. So deployment created a replica set, this created pods. So you're seeing these name values are getting longer and longer because there's things like hashing of the pod specification involved, but that's something you usually don't have to think about. But now if you want to do an upgrade from the 8 to the 9 patch, I can still apply this deployment YAML file again. We would have a new replica set, and what you would see is while these new pods are being created, it would continually scale up the new replica set and scale down the previous replica set. So at the end of the day, we're always having, I think, 2 containers running. So it would start new ones using the new version and then terminating and cleaning up the old ones. If we do it, this is basically the default. It's rolling deployments, rolling updates. But I know that especially when you're working with existing software, with like legacy software, this is usually something maybe your application can't do yet. So you can also use the recreate strategy, right? If you have like breaking changes in your database deployments all the time, maybe you want to use recreate. So in this case, we could apply the deployment YAML file. And what you would see is that the first thing it will do is terminate all the running pods, and then start 2 new ones again. Right, so now we've got the things running. The next thing is how do we...
There's a question.
Blue-green deployments. So basically deploy 2 different versions of the application side by side and then switch over. Is that what you want to think about? That's actually not very well supported. So I try to use recreate when I know it's not possible, which basically kills the application. What you can do is basically have a load balancer in front or using ingress definitions and deploy new things, like you can deploy it with a new name, and then at some point switch over the basically the load balancing configuration. That's not very well supported by the tools that are out there, but if you're writing your own scripts, you can totally do that. But I've usually been fine with recreate, and so recreate is something you would typically use for things like databases, where you can't really have a cluster of different database versions running it again side by side, or you want to reattach the same storage to a new version of the database, which you can't do with rolling updates. So this is where you usually use recreate. Have you actually done rolling updates? So currently not. It should be possible. I think I'm going to come back to that later when we're talking about Helm, because there are things that Helm can do there. So, okay, current status is we've got some things running in there, right? So the next question is, how would you access these things, or if you have multiple containers, how would they talk to each other? And these things are called services. So services are basically allow you to create some abstractions over communications. So a service is basically a DNS entry. So you can specify DNS entries for things in the container. But you can also get IP addresses that you can use to connect to different services. So there's a few different kinds of services. So I think the easiest one is basically a cluster IP, which creates a unique IP address that if any pod wants to communicate with this IP address, the traffic is routed to one of the instances of the pods matching that service definition. And also, all of the pods also can use DNS to get to this IP. There's also ways to, like node port is on each node, like physical node on the cluster, it would open a port and then use that port to map to a one of the instances of the pods that are running. So this is usually something you would use together with external load balancers, where you would just tell an external load balancer you have to just call any of the nodes on this kind of port. It's usually in the high 60-something ranges. And also there's a type load balancer, which is basically what you can also use to to configure external load balancers like Azure load balancers to make your application available behind them and configure these load balancers. So I've also got a demo for that. So we already got our deployment running. Quick check in Rancher, there it is. And we can actually use the command line to create a service for this deployment. So we can use kubectl expose, and we will want to expose our deployment called demo frontend with the type cluster IP. And now what's created is a service. And you see this has an IP. So any port that wants to communicate with this IP address would get routed to one of these instances of these front-end ports, right, on port 80, because we've specified that port 80 is public on these ports. If you have a look over in Rancher, this is also listed here under service discovery. And the way this works is I actually also prepared a small container. So if you have some other container in there, so I have a small busybox container here that basically is a running container that does nothing, but we can simulate some work in there because kubectl also allows me to get a shell access into containers. So we can use like docker exec, we can use a kubectl executes exec. We want to have an interactive terminal into my busybox pod, and we want to run the shell. So now we have shell access in that container. So what we can use in there is NSLOOKUP to look up the IP address that we want to connect to using demo frontend. So if you just want to connect to the demo front end, so talking and typing. Actually in busybox, I think there's an Alpine bug where it sometimes can't find it. But the idea is, yeah, there it is. You have these long DNS address, demo frontend.demo, that's my namespace of services in the local cluster. So you would get this IP address for the frontend service. And now if you want to get an HTTP access, I can do a wget and I could just use HTTP demo frontend to connect to the service. And this is also the same thing that you could use in microservice deployments where you just want to talk to a different type of service. So you could use the name of the service definition as a DNS name in your microservice configuration. Right, so here's the Nginx response. Right, let's get out of there again. And actually what I'm now also going to do is let's delete this service again. Actually, I've got another one with a different name. So I showed you the cluster IP type of service, but there's also this load balancer type of service. So this is how a service definition would look in YAML. Also kind service. And we would select a type, a port that we would run to, and a selector. So the selector is basically the same things that these deployments and replica sets use to locate what's the current state. Is this service would route the traffic to one of the ports matching this label, in this case tier frontend, which is what I've specified in the metadata in my port template. But in this case, if I deploy a service with type load balancer, now what happens here is basically I've got another cluster IP here in the service, but now it says external IP pending. And I can actually show you how this works under the hood if I connect to the Azure portal. So, right. So the way Azure Kubernetes Service works is it actually creates a resource group behind the scenes. and puts all of the stuff in there. And what it now does is it will provision new public IP addresses, configure an Azure Load Balancer instance to point to the cluster nodes using that IP address. And now this is now the power of these abstractions. This has now got this external IP. Okay, my shift control isn't working, so I've now got this external IP, and I should be able to reach my service using this freshly provisioned IP address that I got from the integrations with Azure and Azure Load Balancer. So really, I think this is kind of the thing that we talked about earlier. So you actually avoid vendor lock-in when you do the application development, application configuration, because what each cloud vendor or each on-premise installation does when I say, yeah, please give me a load balancer for my application, maybe something different. So I really think that gets actually out of vendor lock-in. So actually, let's delete this load balancer service again. And we would also see these public IP addresses being deleted from the resource group as well. But since we're doing HTTP, there's another way to deal with HTTP traffic inside of Kubernetes, and these are called ingresses. So basically, these services are like IP layer load balancers, and the next layer, like application HTTP layer, would be ingresses. These would be layer 7 load balancers. So in an ingress, you would define how traffic that comes externally into your cluster is routed inside of your cluster to the target services. So you would point ingress rules to services, and the ingress rules basically tell you, yeah, if you've got HTTP traffic on that host name in this subpath, like you can route different subpaths to different services, then route it to this service. And the idea how this works is actually also an abstraction as well. So your application would contain these ingress definitions, but on the actual cluster itself, you would run an ingress controller that actually also runs some services inside of Kubernetes, like Nginx as a reverse proxy or HA proxy. There's also fancy new ones called Traffic, or you can use different plugins. And these would then implement these kind of control loops. So the control loops I've talked about before, like for deployments and replica sets, are done by the Kubernetes management plane, control plane. Now, these ingress controllers would also talk to the Kubernetes API to find out which rules are deployed by different applications, and then configure their own reverse proxy instance, like Nginx, to follow these rules. So what I've set up behind the scene is I've created also a namespace with my ingress definitions in there. So I just used the Nginx ingress controller using the default documentation for deploying it. You just Google for Nginx ingress and it tells you which commands to run. I've also configured something else, a nice piece of software called Cert Manager that is able to actually get me Let's Encrypt certificates based on the host names that I specify in my ingress rule. So I can also use HTTPS as well in there. So let's go back to our namespace. So we've got this service running in here because ingresses can only point to services. I actually forgot to show you a nice graphic. So you would have this traffic coming into your cluster, and it would hit on these ingress services. So, and depending on the rules you deploy, you can route different domains, different paths to different services, and in turn to different pods. So you can serve a single page application from an Nginx pod, and then route everything behind like /API/something. We could route that to a different backend service. So the way an ingress rule looks is this. So basically it's got a name, and you specify these rules. So for the host demo cluster, das Mulle AT, for the root path, route it to my demo frontend. If you want to use TLS as well, in this case, I've set up this cert manager stuff. And now you also see in metadata, we usually only had names and labels. There's also a different type of metadata called annotations. Those are basically key value pairs that are like not used by this kind of selection stuff for the controller we've talked about. So if you use different plugins, like in my case, Cert Manager, this is a great way to specify some additional metadata for stuff that looks at the resources and tries to configure stuff based on resources. So in this case, I also added a TLS section, and I can specify, yeah, for this host, use this secret name, or actually use the secret name for this with these host definitions. And what the cert manager would do is get me a Let's Encrypt certificate and actually create this certificate in there. So if I deploy this ingress rule, so we see the host listed here. In Rancher, there's also a load balancing section, which also shows these kind of stuff. So actually, I've set up my DNS as well to point to this cluster. So if I go to the demo cluster, das Mulle AT, I would be routed directly to this ingress service. I'm not sure. No, it doesn't say initializing anymore. So I've now successfully set up an HTTP ingress, and also used a bit of open source software to get good HTTPS certificates and HTTP to HTTPS redirection out of the box. So that's not something I implemented in my application now. Okay, so that's a lot of YAML files. Also, that's a lot of individual stuff. So what you would do, actually, let's delete all that stuff again. I just need to type. Okay. I think my E is stuck. Okay, so now if you want to have a large application in there, I've also got a sample in there. So in this case, our application is a single-page application front-end that we want to host in Nginx. We also have a backend service, which is a .NET application that is serving an API. And we also want to use a database. So we want to use Postgres in this instance. And of course, it's what every basic application is. It's a to-do application. So we want to manage our deploy our to-do application to Kubernetes. So I've also already created Docker containers using Docker files for both the Angular frontend and the .NET Core backend, and already deployed them to a container registry. So the way this would look is, again, as I said, you basically throw YAML files together and to become sentient. I've created the definitions for the deployment. So for example, for the front end, I would have a deployment deploying this this front-end application. So I've got my das Mulle demo Azure Container Registry. This is basically a deployment as I showed before. I've got a service for this front end, similar to what I showed just before, a cluster IP. I've also got a backend deployment and a backend service, and also ingress rules that are set up to route everything correctly in this to-do demo cluster, das Mulle AT. but I'm routing the root path to my Nginx container that contains the Angular frontend. So I can serve my Angular application and everything that's behind /API, I want to route to my backend, right? But now there's also a few things involved. For example, my deployment may be a little bit more complex. Maybe I want to configure stuff. And the way we usually like to configure things in, like with Docker images or containers, is there a few different ways. But I think the easiest one is actually to use environment variables, because ASP.NET Core can use environment variables to supplement the JSON files, so like app settings JSONs that you create. So for example, if I just create an ASP.NET Core application and try to run it, it would try to bind to port 5000. But I can also use this Castor endpoints HTTP URL environment variable, or in JSON this would be nested objects, to set a different value. If you've seen different examples in the .NET documentation, you usually see these separated with colons. Actually, we can't use this in Kubernetes, but for this reason, the .NET Core configuration system allows us to use 2 underscores as a separator. So I can specify them directly in there, but I can also use a different type of Kubernetes resource that is very handy, where you want to have some shared configuration across multiple services, and these are called config maps. So the config maps is also basically a file or a resource containing not a specification, but some data. So we basically have key value pairs matching our configuration, so we can set additional environment variables or different. You can also put files in there. So in this case, we want to set our connection string to a value, and maybe if we would have multiple applications connecting to the same database, which you could discuss if that's something you should do or not, maybe not. You could use these in different services. There are also ways to actually use these as files inside of the containers as well. But I think environment variables are very good to get you started. So I have my backend deployment and my service. So if I want to deploy all of that, what I would have to do is use kubectl apply need to go to the right directory. So deploy the config. Okay, apparently I already deployed it at some point. So I've created deployment. Now let's create the backend service. Then I want to have my front-end deployment. My front-end service. And now all of these ingress rules. So, and in a few moments, I should be able, right? So Rancher also shows me these rules. So if I go there, yeah, there's my to-do application, right? And as many of you know, I like to use OpenID Connect, so I can actually log in there using GitHub. Right. And I should be able to create, yeah, let's set it to today. I should be able to create to-do items. Or should I? Actually, I forgot something. I forgot the database. And so this is also something that gets kind of problematic, is when you have large applications, you need to manage multiple files, right? So there's a tool to help prevent that, but I want to show you later because I actually didn't plan to forget the database. But in the database, I can also show you a bit more types of resources. First, of course, if you have YAML files, you can also put multiple things into one YAML file and then use these dashes as a separator. So in this case, there's also a service, a cluster IP services on the default port for PostgreSQL. Now there's also a secret. So a secret is kind of similar to a config map. So you can set things that you want to keep more secret as configurations. That's also some kind of abstraction. So in practice, the difference between secrets and config maps is usually very small. The idea is that in some future version of plugins from cloud vendors or on-premise system, you could use like hardware encryption modules to store these things. But now these are just base64 encoded values. So behaving very similar. But now there's also some things in there. So for example, for databases, I want to have persistent storage. So I'm asking Kubernetes, yeah, I want some storage, please. Please give me a gigabyte of things. And these are called the persistent volume claims. So Kubernetes is going to provide me with a persistent volume matching these asks. And also because I'm on Azure, I can select different types of storage. So this is where there would be a default configured. So if I don't set this, I would get some sensible default. In this case, an Azure disk, but Azure also has premium solid state disks, and I can get to those using the manage-premium storage class names. So there are also storage classes backed by different storage provider, by different plugins. You can also deploy some additional storage plugins. But in this case, if you create a Azure Kubernetes service, you can just use managed premium as well. So, and then the database is also just a deployment, just with one replica, recreate. I just use the Postgres container in there, also map the user and password environment variables into that. Now, but in this case, I'm not pulling them from a config map, but from a secret, which works just in the same way. I can use value from the reference to a secret with a key and put it in there. But also I can tell the deployment to also mount this storage. So the reason there are now multiple things containing volumes and volume mounts is because a pod could have multiple containers in there sharing the same volume. I actually tell the pod which storage to mount into the pod, and then also tell each container that's running in that pod to use this storage name. So these volumes that's backed by persistent volume claims. And also, if I show you this in Rancher, you would see a volume. And now I deployed some more. It's deleted. And now this would be my persistent volume claim backed by the managed premium storage class. Also, if you look into the Azure portal, we would see more of these Azure disks being created and managed by Kubernetes. But again, I don't really have to care too much about that in the YAML file itself. So I'm actually not sure if I'm able to connect to the to application again. Let's try that again. Okay. The way I implemented database migration is I do it at app start, which is also something that's not very good to do. Like this is one of the instances that Fabian asked about, like, yeah, how do I manage databases? Yeah, it's complicated, but there are tools to help in there. So I should now have a database waiting for me to, yeah, demo Kubernetes. Right, let's log out again. Nice, so this is apparently working, but of course you've seen that it's kind of a bit of a pain because you need to like change a few of these YAML files and then deploy them maybe in the right order. So there are ways to deal with that, and what you can use there is black. So is Helm. So multiple YAML files, and it really gets quite complicated quite fast, because you need to have a deployment, a service, maybe some config for each service that you run. And what you would do using Helm is you would package these things together into a chart. So a chart that the helmsman uses to navigate the ocean. And you would provide some configuration mechanism. So you would have the chart and also some configuration values. And Helm would then create all these different YAML files with the values that you provided through the configuration. The way this works is these are actually Go templates. So you use another abstraction over the abstraction. So you use a templating language to actually render all these YAML files. And the way this works is you can define value files. You can use value files during deployments. You can set overrides during deployments. But of course, you can also package these charts together. It's just a gzip tar file and publish them to Helm repositories. And also what's a very useful feature is you can use subcharts to include different charts. So for example, I created my own definition for PostgreSQL databases, but there's people who already know how to configure all the YAML files needed for a PostgreSQL database. So if I want to create a Helm chart for my application, I can just use the subchart for PostgreSQL that contains all the right defaults and all the right setup for PostgreSQL. So also maybe I want to set up a MariaDB cluster or use the Microsoft SQL Server images in maybe a cluster configuration. And there's usually Helm charts already available containing these configurations. So I've also already set this up here. In this case, this is how a chart looks. I'm not going too much into detail about what you can do in there, but the idea is you would have basically a YAML file that tells me, yeah, this is a to-do list, a to-do application, and also says, yeah, I actually have dependencies. So just like you would specify any node dependencies or NuGet packages, you can pull in this case, PostgreSQL from a company, Bitnami, that makes quite good Helm charts. So you would specify a chart version, and all these values file that you would configure, you would usually put defaults into a values YAML file, and those are used during deployments, but you can also override them during deployment. So in this case, I can set an image tag that I want to use during the deployment in some different parts. There's a lot of stuff that comes in from a default Helm chart template. But in this case, I can also specify values for the PostgreSQL subchart. So these values are then passed on to the PostgreSQL subchart. So you can also specify, yeah, I want persistence, but only a gigabyte. And I want to set the username and password for the default user. And I could also do some different customizations. The way you would do is you would go to the subchart definitions. So there's actually a hub for these charts. Slow. Now the Helm hub. I think I'm streaming too much. Okay, but the idea is just like you would go into Docker Hub and also use some Docker README files. There are README files specifying what values you can use during Helm deployments. Okay, so now you will also see that I've got some custom values that I can use. So the templating language takes a bit to get used to, but what you would do now is, for example, there are configuration options. So I can set the host inside of the YAML files or during configuration. And once I want to render these ingress definitions, I can use a kind of templating syntax to render these values. So you can have ifs in there, you can use variables, but you can also, in this case, this is a for each loop over this with this YAML array, where it would just render stuff out there. So you're basically creating rendering templates for YAML text files. What's also interesting is you can have some shared templates that you can include and use otherwhere. So for example, there's stuff that tries to use some, if this is not set, use a default, truncate it to some characters, remove trailing dashes, for example. And if you use something like deployments, you can use these shared functions as well. So these are the ways you would use to configure these templates. For example, you can also change the replica count, for example, using these templated definitions. But I think I'm not going to go too much into detail. So it takes maybe a few days to get into the intricacies of Helm templates. But if you just create a new Helm chart using I think Helm create or something like that, you will get sensible defaults for most of the stuff, and you can just follow the templates and examples out there to create your own. An interesting thing that's a feature of Rancher, which I like a lot, is this questions file. So for example, here I can define questions. So I can define, please set this variable with this user interface. So this is basically a user interface configuration that allows me to change some of these values during deployment. And if I go over to my Rancher instance, so Rancher has these apps features. So what you can do is you can use catalogs, which are basically links to these Helm repositories. And actually each Azure Container Registry is also a Helm repository. So I can add the Helm repository backed by my Azure Container Registry to Rancher, and then use the Rancher apps feature to deploy my application using my Helm chart. So I can use launch. I have my to-do list in there, right? And actually, let's create a new namespace. To-do list meetup. Let's also name the instance of this application like this, to-do list meetup. And now can answer these questions that I've asked. So for example, I've made ingress optional. So if I want, I want this ingress, I want it to be available publicly via HTTP, I can turn that on. So I can use, for example, to do meetup.demo cluster. I've also made this TLS configurable. So I want to have TLS. Let's use a secret name in there and get a certificate for that domain. And I can now select the storage class name. So I previously showed you in Azure I have premium SSDs, normal SSDs. I can also use SMB sharing to mount Azure storage accounts, but now let's use default for now. And then I can actually launch the application. So what it then does is it renders all these templates for YAML files and then renders them one by one. And now it deploys all these files. So I don't have to use command line automation to render all these files. Additionally, there are also some interesting resource types that I didn't talk too much about. One of them is actually jobs. So I can also describe a pod that should only run once to completion, which is like a batch job that you could run. So, what Helm now offers is also Helm has some what's it called? Basically some extension points that you can use during installations and upgrades to run jobs. So for example, I could run a job during a hook. I can register a job as a Helm hook, so that every time I update my Helm chart to a newer version, I could maybe run the migration script first and then update all my deployments. right? Because exactly of these update strategies, there's also hooks for installation. There are hooks for uninstallation. I think there are also hooks for doing rollbacks. And the way you would manage these is basically you can basically roll back and forward between different template versions. And at some points, these resources would become available. Now, what you will also see is usually it takes a bit of time if you need to provision new storage and mount it somewhere. So yeah, we just took a few seconds to actually mount this stuff, and I think the database is now becoming ready. Listening. My backend started, and now we've got this to-do meetup instance. Yeah. Let's log in as Bob. And it works. So these are ways to really package applications up and configure them when you want to install them. I think this is also very interesting to do during continuous integration and continuous deployment scenarios where you could maybe automatically create new Helm charts and then use build promotion to roll out these charts for different environments, and then use these basically value overrides for each environment to specify different values for your application. So that really helps for rolling out applications. All right, I think there's only a few other things I could still talk about. So, sorry, the concept. So I've briefly mentioned jobs. I also want to tell you that please try to look at stuff where Kubernetes can actually help you do stuff that you would normally do inside of an application. And I think one of them is doing regular things like cron jobs. Kubernetes actually has a scheduler that is able to run some tasks as a cron job, right? Because you've got a system that can do scheduling. There is no need to build scheduling inside of your application when you deploy to Kubernetes. You can tell Kubernetes, here, please run this pod, this container every 5 minutes because I want to do some cleanup stuff. Or batch processing using a queue. You can fill a queue and tell Kubernetes, yeah, please run 10 instances of these jobs, which will then run until completion. And Kubernetes will also try to maintain this parallelism for batch processing that you said. So if you look into it, there are a lot of ways that Kubernetes can actually help you offload some concerns that you would previously have to implement manually. So with that, I'm actually done with my content. So if you have more questions, please shoot. I wasn't able to monitor the screen that closely. Poor Quartz. Yeah, Quartz and what's the other one called? Too many scheduling stuff. Okay. There was one question about having Helm charts for different services and then have a grouping Helm charts. Yes, you can do that. I would question if you need to do that. So if you reuse the stuff in different applications that you build from different repositories, this is definitely something you could do. I think then it's the same concern as if you want to publish each library that you write as a NuGet package. If it's all in the same Git repository, then maybe you don't have to do that. But if you create a shared services that it's used by different aggregating services, so maybe you have multiple companies developing different services, these are totally things you could do. Up-to-date info on AKS. Yeah. Bad stuff about it. Yeah, there's good and bad stuff. So my experience was actually quite okay. I've bumped into some stuff because I was trying to do high density test deployments on very small nodes. And it turns out those smaller nodes can only mount a limited number of disks. So if you want to run multiple instances of Postgres and InfluxDB and want to have RabbitMQ with storage, that actually explodes quite fast. So you need to look into different storage solutions as well. So some things will work with Azure Files, like Azure Storage Account mounted with SMB. Some things don't. Like I think InfluxDB uses a very, not ancient, but already an out of support version of some storage system for lead election, like BoltDB, that does some file operations that are not supported by SMB. So you may run into issues there, because also Azure doesn't schedule pods using volumes for Azure disks necessarily on nodes that have capacity to mount disks, because those are not scheduled resources. So that's the only limitation I hit with Azure. But of course, there are other systems. So for example, in on-premise solutions, or you can even run that in Azure, you can use systems like Longhorn. I'm not sure if I deleted it already. Yeah, I did. Those are basically different plugins that you can use to use storage. So for example, Longhorn deploys services on each node that basically use microservices that do it's microservice-based distributed storage. You can do that for block storage and file storage. There are things like Ceph that are also doing something similar. Maybe not that well for very small scale deployments. Should I use Krieger? Yeah. So there are different container runtimes. So again, Kubernetes is a bit of an abstraction. You don't have to use Docker. You can use different container runtimes. Honestly, try and see what works best. I like that in the back it's all Docker based, and for example, I also like to use the logging integrations by Elastic. So Elastic actually has stuff that you can deploy to your nodes. In this case, it's not a deployment; it's what's called a daemon set. So things that you would run once per node, and it just grabs the Docker JSON log files, uses the Docker metadata to annotate it, add some Kubernetes metadata. So that works very well. But yeah, there are different container runtimes that Kubernetes supports. I've just stuck to Docker, but yeah. Hangfire was the other scheduling engine. Yeah. Good. So, while downscaling, will a pod be reasonably stop? Yes. There are different ways. I think it's the same things that are used by the container runtime. So like if you do a Docker stop, if you use the Docker runtime, it would try to gracefully stop the container with, I think, the default 10-second timeout until killing. How would you monitor pod metrics? So that's also an interesting topic. So Kubernetes also has some integrated metric things. Actually, if you use Rancher, you get a little bit of a dashboard already, like what kinds of things you use. But of course, you can use different integrations. So you can use export these metrics to Prometheus or also to Elastic, and Rancher even helps you set up logging and monitoring into a few things that it has predefined integrations with. If that is what you mean. Okay, so I'm not seeing too many. Okay, perfect. Yeah, if you need something different, just shoot me a mail or tweet. So then with that, I'm actually done. So thanks for your patience. I hope I could help you. I think there's going to be a feedback link, so I'd be very glad to get some feedback on things that you didn't want to see me talking about too long or stuff like that. Just Just shoot me a message.
Good. Thank you, Martin, for the talk. Good. Some final words. Yeah, thank you all for joining today's session. And again, thanks to our sponsors, Tieto, for supporting us. If you or your company want to sponsor us, or you want to host a meetup and we finally can meet again together, talk with us. We made a page with some general sponsoring information. Let's put this into the chat, and yeah, there's some suggestions. Talk with us, and we figure something out. Next meetups. Next May, the May meetup on the 5th is about state of observability in .NET. It will be streamed again as this and last time. The meetup notification should already be out there. And for the future, we're planning to do the June meetup also online only. And let's see if we can meet again in July. As you can see, the topics are yet to be defined. We don't have now fixed speakers or topics, and that's where you are needed. We would like to know which topics you would like to hear in the meetups. So we created a GitHub repo where you can put requests in, and what topic you would like to hear. And we are then looking if we can find a speaker for this topic. Sorry for the background noise. Some of my neighbors started to drill holes into the walls 5 minutes ago. So I hope it's not too loud on your side. Other related events that are happening is the Global Azure Bootcamp is on the 24th of April. And the Austrian version that's normally in Linz, this will be now also online only, and there are some cool talks there. Martin is again a speaker there with his OpenID talk, when I remember correctly, and some other cool stuff. Good. One thing, please spread the word that we have these meetups and provide you with all this information and knowledge. Invite colleagues, invite friends, invite your customers, tweet at .NET devs.at and invite everybody who has that has something to do with .NET. We want to grow this community. Here again the links to us, to .NET Devs homepage, Twitter, Twitch, YouTube, and the Slack channel. Recordings of all the talks are on the YouTube channel. I will put up the recording of this talk in the next days. Yeah, and one final word. We always want to improve our meetups, so we have a small feedback link with a small survey. It would be cool if you can fill it out. That gives us feedback that we can improve this whole meetups, the online onlys, and then also the real person ones. Cool. And as we are always experimenting with stuff, we're also experimenting this time with something. To get a little bit of the socializing character of a meetup or so, we have afterwards chance to talk to each other about topics and other stuff. We have a Zoom call running. I'm sharing the screen now with you, It's already open. You can join and let's hang out a little bit, and if you have still questions for Martin, he can answer them also there in the Zoom call. Cool. Then again, thanks for joining, and I hope I see some of you now in the Zoom call. Bye.